Solving logarithmic equations, part 2. This is not more difficult, but different. So we have 2 log base 3 of x is equal to 3 log base 3 of 5. And this is what I want to make sure that everybody is clear on, and that's that there are these properties. And there are 3 major properties that you really have to know, and this is one of those. That if you have a coefficient value right in front of log, that value can be expressed differently, and it can be expressed as an exponential value of the argument here. So this can come up to here, and this can come up to here. So if we do that, we're able to kind of unlock the rest of this stuff. So we have log base 3 of x squared, this 2 is this 2, is equal to log base 3 of 5 cubed, this 3 is this 3. Is that all right? From here, we can take the log base 3's out because log functions are 1-to-1, and that's an explanation you could give to your professor. So we can drop those and get x squared is equal to 5 cubed, and we're solving for x here. So x is equal to the square root of 5 cubed. And if we went back and tested that, we'd see that that actually works quite well. So we'll put that in up here, and here's the original equation. Log base 3 of, right, we're here now, log base 3 of square root of 5 cubed squared is equal to log base 3 of 5 cubed. Well, of course, the square of a square root is just that, isn't it? So check, that worked out good. All right, maybe we take, do we have another quick one we can do here? Yeah, here's one we can, let's take a look at this. Here's one we can do right here. Just taking the ones that I solved today that really seemed to, oh, here's the one that killed everybody. Let's take a look at this one. So it's this, it's log base 6 of 2x minus 3 is equal to log base 6 of 12 minus log base 6 of 12 minus log base 6 of 3. And for reasons different than what you think, this is going to come out to be 0, because if we look at, this means division to us, right? So when we see this negative sign, this one here and this one here, we are supposed to think division. So what I'm going to do is this, I'm going to take log base 6 of 12 over 12, which is of 1, isn't it? And 6 to the 0 power, so this is 0 minus log base 6 of 3 equals log base 6 of 2x minus 3, right? So from here, this should get better for us, I hope, right? So here, we're just going to get all right, sorry, I had my pen was glowing weird on me, so I had to take a look at that. Here's what I'm going to do with this one, and this is kind of where people got a little thrown off today. Here's this negative sign. We remembered from conversation we just had that if we have a coefficient, and this is a coefficient of -1, it goes up as an exponential value. So what we really have here is log base 6 of 3 to the -1 is equal to log base 6 of 2x minus 3. Okay? So that's kind of bothersome, I guess. Now, because log functions are 1-to-1 functions, we're allowed to drop this and this. And we get 2x minus 3 is equal to 1/3, right? Because we know that a to a negative power is 1 over a to whatever power that is, where a is not equal to 0, right? So I'm going to add 3 to both sides, but of course 3 is the same as 9/3, right? So it says 3, but I'm going to call this 9/3. That's still 3, isn't it? So I'm going to add 9/3 to each side is equal to 10/3, isn't it? Right, going to multiply by the reciprocal here, so multiply by 1/2, and we are going to get an answer of x is equal to 5/6. All right? Okay, this is a ton of work, but it's really worth it. And I think this is one of those things when you get this and get it well, it helps out so much in AP Calculus. So if you have questions or comments, please share them with me. And if there's something I can do to help you, please let me know. Peace.